anything with 7.3 that we need to go over up here? Are you guys okay with that part? Not getting anybody questions out of you, so hopefully you're okay. Also, that 7.2 and 7.1, I didn't hear from some of you because you're supposed to let me know if you were going to get that finished. So I'll go back in and check on that and see what you've accomplished with it. Okay, so 7.4, A and B. You have, I handed out to you the story problems, most of the ones that we're going to cover in here, so that you'll have those, so you don't have to write them down. There's a couple in here that are not in that handout, but we'll work on those and see what we can do with it. 7.4 is broken into two parts, A and B. Part A is dealing with proportions, but they're algebraic proportions, and so they're a little bit different, not a whole lot between those. So if we continue on, so we're going to look at solving proportions as our objective, and then solve other equations with rational expressions. So that's our main goal today, is to get those two out of the way. And when we get into the proportions, we've got some story problems that are involved in there, and so forth. So let's take a look at what a proportion happens to be. So a proportion is an equation stating that two ratios are equal. The symbols A over B equals C over D is a proportion. If we had normal proportions, such as 8 over 10 is equal to 16 over X, we could simply take these and we would cross multiply them. X times 8 is 8X. 10 times 16 is 160. Divide by 8 and find out that X is equivalent to 20. And so we would end up having 20 for our denominator in there. But not all of our proportions that we're going to work with in intermediate algebra are going to be in that format. Some of the proportions that we have are going to look like so. They're ones that involve having denominators, and so we're changing. We've moved from having expressions. Everything we've had in the past has been expressions, meaning that they haven't had an equals. Now we're getting to where we have an equals in here, and that equals means we need to be able to solve these and come up with what X actually equals. If I said, okay, look at this first one and tell me what X is going to be. Can anybody tell me? Probably not, because it has two different places in there in two different pieces that you're working with. So what we need to do with this one to solve it is we still need to find an LCD. So what would be my common denominator? And we should be good at doing this because we practiced it before. So what's my LCD, or the common denominator between 2x and 3x? Anybody see? What should it be? What was it? Somebody said it, I think. They say it? 6x. Yep. 6, because 2 and 3 will go into 6. And x is part of both numbers, so therefore we end up with 6x. So now what I'm going to do is I'm going to take each separate piece and multiply that by 6x and multiply that by 6x. The reason we can't just do that simplification and that cross multiplication in there that we have is because we're getting involved with having an additional x in place. So to do this, what happens now is that the 2 and the 6 cancel, the x and the x cancels. So what happens with every one of these is your denominator is going to disappear. And we're going to find that throughout all of these, throughout this whole section, that that denominator is going to go away. So what I'm left with is 3 times x minus 5. You guys able to see that in the back row? Yes? Okay. Because I know sometimes it gets a little hard back there to see. So then this 3 and this 6 cancels. The x's cancel. So I'm left with 6 times 2. So now if I go through and solve for x, just like we did in basic algebra, 3 times x is 3x. 3 times a negative 5 is a negative is minus 15. 6 times 2 is 12. Then I'm going to add 15 to both sides. And so I'm going to find out that 3x is equal to 27. divide by 3, and I will find out x is equal to 9. So I get 9 for my answer. So if we check this and we went back up to what our original statement happened to be up above, we would end up finding out that these two sides would end up being equivalent to each other. And you'd have to reduce some sides, I would imagine. 9 minus 5 is 4. 2 times 9 is 18. Then I have 6, and 3 times 9 is 27. But if I cross multiply in each of these, I will find out that they equal each other, so I know I did it right. One other key thing you have to be careful with is last time in 7.1 we talked about restrictions. Restrictions were when we could not put something in the denominator that made the denominator become 0. And the reason we can't have 0 is because it makes everything undefined. Okay? So if they come out undefined in there with some answer that I have, then I need to watch that and not use that answer. But 9 is not going to make either denominator become 0. The only thing that would make these become 0 is 0. So x could never equal 0. Okay? So you'd have to be really careful with that part. So then, if we look at the second example up here, I still need to find my LCD. So what is it going to be? So what would my LCD be? From 7.1 or 7.2, we found out that we need everybody from the first one. And then we got to look at the second one and see what part am I missing. This had x minus 6, but this has an x, so I still need an x in my denominator. Now this one you could do the old-fashioned way of just doing your cross multiplications that you normally would do with proportions because there's not an extra common variable. This other one we had over here had x as a common piece, so I had to be real careful with that. This one, each piece is separate, so I could just say x times 3 and x minus 6 times 5. So you have to look at them carefully to know that. So this whole piece gets multiplied by x minus 6 and x. So x minus 6 cancels, so I'm going to have 3x. In the other one, the x part cancels, so I have 5 times x minus 6. We good there? Okay, so what do I get out of this? Well, I have 3x. 5 times x is 5x. 5 times 6 is minus 30. Get my x's all together. So I'm going to minus 5x. So I get a negative 2x is equal to a negative 30. Divide by negative 2. And I'm going to find out that x is equivalent to 15. And so 15 should end up making each side of this fraction come out correctly when we work with it. So that's the part that we end up having to take a look at. So if I look at and plug 15 back in to check, I have 3 over 15 minus 6, which is 9. 5 over 15. If I reduce both of these, I end up with 1/3, and I also end up with 1/3, so I know I've completed it and did it correctly. So with our proportions, again, finding that LCD is the important part, and we should be pretty good at that from 7.2. Everything you learned in 7.1 and 7.2 is what we use for the rest of the chapter. It's the ground floor of every piece that we're going to work with. So we just kind of up it a little bit by changing something that we're going to do with it. Questions on either of these two? Okay? Okay. So that's that part. Then what they end up doing is going into a bunch of different story problems. And this is the sheet that I handed out to you at the beginning of class. So you guys should have that one. The proportion story problems will always have inside of the story problem, they will have a proportion or a ratio that you happen to have within those. And so we got to look for what that ratio is going to be and then set another one equivalent to it. So if it took 9 hours to drive to your cousin's house, how long would you estimate the drive to Disney World? The distance to your cousin's house is 333 miles, and the distance to Disney World is 740 miles. So how can we come up with a ratio out of what we happen to have? So what do we have in this? Well, we have hours and we have miles. So we know it took 9 hours to drive to the cousin's house. So how long is it going to take to drive to Disney World? So 9 hours. What's 9 hours connected with for distance in my problem? 333. So I can put 9 hours over 333 miles. Then next to it, this is to the cousin's house. This over here is to Disney World. And so, do I know how long it took me to drive to Disney World? No, that's my X, hours. And we know the length of time is going to be 740. And so now I can solve this using my normal proportions because I only have an X in one certain location. So 9 times 740 is equal to 333 times X. So what's 9 times 740? You got their calculators out there? Multiply that thing out and see what we get. Everybody have it? Yep. And then it's 333x. And then finally, to get x by itself. And what does that give me? These cancel and leaves me with 20. So we need to figure it's going to take 20 hours to get to Disney World if we drive at the same speed we drove to the cousin's house. So is this problem really realistic? Do you think you'll drive as the same speed? Probably not. In some cases, you might drive faster. You never know. The land might be different going to Disney World, so it really doesn't tie in there very well. The next one, see if we can set that one up. If it took 6 hours to drive to your brother's house, how long would you estimate the drive to Las Vegas? The distance to your brother's house is 276 miles, and the distance to Las Vegas is 1,380 miles. Same kind of problem. See what you work it out and see what you get for an answer. And I will put up here the steps that we go through to do that. So you should have, it takes 30 hours to drive there. Am I get 30 okay? It takes me longer up here to write it up than you guys to solve it, because this is just, again, a really straight proportion that you're working with. The bottom one here says, Frank is investing his money. He thinks that he should make $15 for every $100 he invests. How much does he expect to make on an investment of $900? Same kind of process. Notice it's basically the same thing. You set up a ratio. So he's going to make 15 for every 100. If he sticks 900, again, your dollar amount goes in the bottom to end up getting your investment that you'd end up making and coming up with. So that's the piece that goes on the top with that. And so that's what we'd end up having in that one. And so, again, 900 times 15 divided by 100 ends up giving me my final answer. And I end up with $135 is what X is. Okay, are we good? Okay. So, flipping the page. The other piece that they give you for story problems in this section is similar triangles. And if we look at similar triangles, there's a pattern within them as well. So if we have triangle ABC, and triangle DEF are similar, find the missing values. Write your answer in fractional form without reducing to lowest terms. So it says, note the triangles are drawn to scale. So find the value of X. So when I have similar triangles, I need to compare and set up ratios of similar things. Just like I did in the last problems where I put miles to miles and hours to hours. I need to find out what makes things match in here. Well, this side, AC, is a match to DF. Do we agree? They're same sides of the triangle, and so they have a ratio to each other. So in this case, 10 is to X, okay? So 10 is to X. Then I need to find out what I'm going to put for my other ratio to solve it. So to solve it, I need to have sides that I have all my information on. So those sides would be A to B, which is 8, is the same as D to F. So 8 to 13. The top part of this is triangle ABC. The bottom part is triangle DEF. And so I'm keeping my triangles together. There's a lot of different ways to set these things up and to solve those. So 10 times 13 divided by 8. I find out that X is going to equal equals 16.25. So that would end up being what my side would be equal to. Then if we wanted to find Y, we could set this up completely different. This one I went side to sides that matched each other. This time if you want to go triangle, we could go Y over 13. This piece to this piece is equal to 6 to 8. I ended up changing what I was doing with my triangle in there, and I ended up just putting it together differently. So just be aware of that how you set these up can be different from one problem to the other. So Y times 8 is 8Y. 13 times 6 is 78. Divide both sides by 8, and I find out that it's equal to 9.75 would be my distance on my triangle. Okay, does it make sense? I'm setting those up and going from one to the other. Okay, so with similar triangles again, it's just how they end up setting those up. Yes? Oh, well, if we're going to leave it in fraction form, then the only thing that we'd need to do with this one up here, that's true, it did say leave it in fraction form. So this one would be 10 times 13 would be 130 all over 8. Then that reduces because I can put 2 into both of these. 2 goes into 130 65 times, and 2 goes into 8 4. So x is going to be 65 fourths. And y down here is 13 times 8, which is 78. And or 13 times 6, which is 78, and it's going to be divided by 8. And so if we reduce it, 2 goes into 78 39 times, and 2 goes into 8 4. Thank you for bringing that up, because I was supposed to leave it in fractional form. Okay. Yeah. Pardon? Oh, and not reduce. Okay, well, we leave it as it is. Picky, aren't they? Fractional form without reducing. Oh, yes, but reducing to lowest terms sometimes can mean turning into mixed numbers. So we ended up putting those in there. Okay, this one might be a little bit tricky when we get into doing that with the Hawk stuff. So let's see if I can do it right on this next one, because that's the ones that we had in there. Here's another one that they end up giving us with similar triangles. This one doesn't have numbers, but we have values, and so we have to be careful with what we do to solve this one. So how do you want to set it up? So we got similar triangles. Find the length of side AB and QR. So AB is here. QR is there. So how can I set these up as similar triangles? So if I look at it, I can say 6 is to x minus 4 as x is to 10. Meaning that I've got my sides that are matching each other in here. Okay? So cross multiply. If I cross multiply, I get 10 times 6 is 60. X minus 4 times x. I multiply this part out. This one gets a little more complicated because I get x squared minus 4x. Move my 60 over. And we end up with something that maybe we can factor. Does that factor? Are there factors of 60, negative 60 that give me 4 for my center? Sometimes when you get squares involved, of course, got to factor. So we're in that chapter that we can factor stuff with. So I get x and x. What are factors of 60 that give me negative 60 that give me a negative 4 in the middle? Negative 10 and 6. And a plus 6, yeah. Set each of those equal to 0. Solve for this one. Moving 10 over, I find out that x equals 10. This one, moving 6 over, I find x equals a negative 6. So, which of those sounds like my answer to my problem? One will work and one will not. One won't work. So, which one works? Is it 10 or negative 6? Well, I can't use a negative 6 because length can't be negative, right? So negative 6 will not work for my answer. So the only one I can use is x equals 10. So if I look at this triangle, this side is going to be equal to 10. And this side is going to be 10 minus 4 or 6. So that's my two answers to my problem, is 10 and 6. So sometimes you need to take things and do some more factoring with them. and so forth. So that's the key on that part. Questions with this part of similar triangles and getting that to work. Again, match sides. Could have I set this up differently? Sure. I could have set it up as 6 to x as this is to this, but it would still end up working out the exact same way. So how I set my ratios up, as long as I'm consistent, the same sides matching here to the same sides matching there. This one was the same triangle to this other triangle. So your patterns are different in there. So it just depends on how you set them up. Be careful, though, not to invert something and put 6 is to this as 10 is to that. You're getting your sides backwards. So be real careful and make sure it follows through on what you have. Okay. Questions with similar triangles? Okay. So moving on to 7.4b. That last part was all of the proportions parts. And in 7.4b, we're going to look at solving equations with rational expressions. And to do this, these do not have story problems connected to them, but they have multiple things that you might be adding together on each side. So you need to find the LCD of the fractions, and this means all fractions. And you should be good at doing that because it's no different than what you did in 7.2 when we added fractions, or in 7.3 when we had complex fractions and we had to remove your pieces in there. So it's the same process. It's not something brand new. Multiply both sides of the equation by the LCD and simplify. When you do that, the denominators disappear. So don't have any denominators left in there. They all go away. That equal sign allows us to do that with our problems. So they're going to disappear and you're not going to have them in your problem anymore. So watch that and make sure you get rid of all of those. Solve the resulting equation. This equation will have only polynomials on both sides. Again, no denominators. Check the solution in the original equation. Remember that no denominator can be 0. So if you get a number and it makes one denominator and all of the fractions you have become 0, you got to kick that answer out. It cannot be used. So make sure you discard it, get rid of it so it's not there. Then, so that's our main piece to this. So now, what do we have to do with this part? So let's see if we can end up solving it. It looks like the proportion, like we just got done doing, so it's kind of the same process with it. So I need a common denominator. This one's already factored. This one's not. So I need to pull out an x, giving me x minus 5. So find my LCD. What is my LCD going to be? Well, like I told you before, everybody from the first one, and add in whatever pieces you don't have in it from the second. So what am I missing from the second part? I'm missing x, right? Because I need an x. And I'm missing x minus 5. So I've got a lot of stuff that I need to put in that problem. So now I'm going to take this LCD and I'm going to multiply it by each of these up above. So this part gets multiplied by that part, and it's also going to get multiplied by this part. So when it gets multiplied by the first part, the piece that I have in my denominator is x minus 4. So the 1 is going to get multiplied by the x, and it's also going to get multiplied by the x minus 5. But notice I have no denominator now. My denominator is gone. What does 3 get multiplied by? So the x and the x minus 5 are gone, so the 3 gets multiplied by x minus 4. So, multiply it all out. 1 times x is x. X times x is x squared. X times a negative 5 is negative 5x. 3 times x is 3x. 3 times a negative 4 is 12. How about if I write that in there instead of writing 4? So, combine everybody, get them all on one side. So I'm going to minus 3x. Then I'm going to add 12. And I'm going to find that is set equal to 0. Factor it. So what are factors of 12? Positive 12, that give me a negative 8. Negative 6 and negative 2 should be what I have. Set each equal to 0. And I find out that x equals 6 or x equals 2. And can I have those for answers? Will both of those work? If they do not make the denominator become 0, we're good to go. Okay? So, will that make my denominator here become 0? 6 minus 4 is 2, so I'm good there. 6 squared is 36 minus 30, I'm good there. Okay? 2 minus 4 is a negative 2. 2 squared is 4 minus 10 is a negative 6, and we're good there too. So those are both legal, honest answers that I can use in this problem. Questions with this one? Okay. You could have also found out what x could not be by going back and doing restrictions like we did in 7.1a. If I found the restriction of this side, it would be x minus 4 equals 0. So x could never equal 4. And if I did the other one, factored it out, set both equal to 0, I would find x could never equal 0 and x could never equal 5. And so since 6 and 2 are not even any of those numbers, I'm good to go. Okay, so you can always check it. You can always find out whether your answers are right by finding out what those restrictions happen to be. Questions with this one? Okay. Getting a little bit more in depth here and getting a little more complicated as far as it looks more complicated because it's got, of course, more pieces to it. LCD, that's what I first need to find. So LCD. What was that again? Oh, yeah, definitely. That's true. I got to give you time to write it down. That would be wonderful. That one's kind of a long one. Get written down. Or maybe you want to work on it. See what you can do with it. So just keep working on it. See what happens. So multiply that LCD by each piece, and you get that. The x minus 6 doesn't get multiplied by only 1 because all of this is the LCD. So there's anything else it gets multiplied by. Then each of the x minus 2 denominators, the numerator is going to get multiplied by the x that we had in our LCD. Okay? I'm going to get set equal to 0. So that's the important part. And as we said, Chapter 6 plays a big role in here because Chapter 6 is all that factoring piece. So once I get to this point, that needs to be factored. So 4x squared times 6 using that AC method. So what are factors of 24x squared that give me a negative 11? Or use guess and check there, whichever you so choose. So negative 8x plus a negative 3x equals my 11. Replace my middle. Oops, plus 6. Group in my 2's. Set them both equal to 0. So I end up with 2 answers. Positive 3/4 and a positive 2. Can I use both? 3/4 is not going to make my denominators ever become 0, but 2 will. Okay? So the answer is x equals 3/4. So I cannot use the x equals 2 because it makes a restriction in there. So I'm restricted because x can never equal 0 or x can never equal 2. So you've got that restriction happening in there. Okay? Okay or not okay? Did you guys get very far with it on your own? I know I kind of hopped in there and started going through stuff, but hopefully you made it to a certain spot within that. Okay? Here's another one. See what happens on this one. Each denominator has to be factored, so So if we walk through this one, we get our LCD. Again, take everybody from the first. X squared is x times x. X squared minus 3x. Pull out an x to factor it. Everybody from the first becomes my LCD. Second, I need x and x. The third piece, everybody is represented. The x is here and the x minus 3 is there. So they're all represented in there. So there is no need to add anybody from that last one. Get rid of denominators. X minus 3 and x plus 3, gone. Leaves me x squared times 2. X squared piece is gone. Leaves me with x minus 3 and x plus 3. Finally, the end, I get rid of 1x and I get rid of an x minus 3. So I got to multiply 1 by x plus 3 and x. Multiply all that out, gets me 2x squared. X, 1 times this is that, times it by this, goes back to x squared minus 9. 1x times x is x squared. 1x times 3 is 3x. Move everything, get my x squareds. They cancel each other out. Then go down and solve for x finally. And move the 9 over, divide by 3, and find x equals 3. But, what's wrong? Can I have x equals 3? What was that? Yes, in the very first fraction, it makes the denominator 0. So if any one of these becomes 0, it means I can't use the answer, okay? So I cannot use 3. So any one of these that becomes undefined, I cannot use. So this really has no solution. So sometimes that happens, where everything goes away, and you end up with something that doesn't work. So always check your restrictions. If you want, when you find this LCD, it will show you the pieces that make your restrictions. So if you put this equal to 0, this to 0, and x to 0, you would have all of your restrictions. So x can never equal 3. And so therefore it's not a solution. So the statement is basically there is no solution. The solution says an empty set. And the original equation is a contradiction. Contradictions come in when we don't have answers for things. When either all x's disappear and the two values left don't equal each other. So that ends up being a contradiction. So you might want to note that. So we could say the problem we just got done finishing was a contradiction. So somewhere, make sure to note that. Okay? So that's that piece. Then the final piece in this section, they have you solve for a variable within it. And we did this way back in basic algebra where you had to find and get a letter or get a value all by itself. So in this case, we're taking the formula of 2 pi r squared plus 2 pi r h, and we're going to find the surface area. But we want to take our formula and solve for h. So that means I need to get that letter all by itself. So to do that, you're going to reverse the process. So we're going to subtract this from both sides. When I do that, I get s minus 2 pi r squared. Then finally, the last piece is to divide each side by anything that's connected to h. So 2 pi r. And so I divide it off, and I end up with that for my solution. So my answer comes out to be s minus 2 pi r squared all over 2 pi r. Now, you look at this and you think, oh, I can cancel. I can wipe out that 2, and wipe out that pi, and wipe out an r, and all I'm left with is s minus r equals h. Good plan? No, not a good plan. I cannot cancel these because of the subtraction. So be careful and watch and make sure you don't have a subtraction and so forth, so you can reduce that one. Let's see if there's I think there's another one right here that, and first I want to show you, these are practice problems. I don't know, do we need more practice with this stuff? What do you guys think? Okay, so we think we can do this one because we get common denominator 15, multiply both by common denominator here, the road map with 50 miles. A distance represents 4.5 inches on a map. So if each inch equals 50, so it would be 1 inch over 50 miles. And you have 4.5 inches on your map. You want to know how many miles? So that would be simply setting it up that way and then going through and solving it. The other one, though, these, again, are like the ones we just did. I will go back through and work these out, and they will be posted in the notes, okay? So you will have those in your notes if you go back and take a look at that. This one, let's solve this one, though. We'll solve the formula A equals P plus PR for R. So how am I going to get R all by itself? So it's kind of reversing the process. So to get R by itself, what has to happen to this P? Again, reversing what it's doing, it's being added. So to move it, I need to minus a P. And that leaves me with PR. Divide both sides by P. And I'm going to find that these cancel. So R is equal to A minus P all over P. Okay? So that would be my solution to that. So just so you have those in there to get that written down. Again, don't worry about writing those two down. They will be in the notes that are posted in Canvas for that. Okay. Then on the back, these are the answers to the practice problems. I'm going to leave that up for a minute. If you are watching this with a video, you can just pull or stop the video to get your answers out of that. So that would be your solutions to that. Okay. Why don't we take a break and come back at 9 o'clock should work. And then we will do some more story problems because 7.5 is all story problems. So we'll work on that. Okay, back to story problems. More of those lovely pieces. 7.5 has a different group of application problems to it. And so some of these we'll just set up. There's quite a few of them in your handout there that I gave you. And those will pop up in here too. So those are in there. So here's your starting with the application. So we're going to solve problems related to fractions. Yeah, oh, you didn't get one either. And then solve applied problems related to work, and then applications involving distance, rate, and time. So that's our three categories that we're going to work with within our story problems to end up solving those. So strategies. Read the problem carefully. Read it several times if necessary. So if we have to go back and you have to read certain things, pay close attention, because it seems like every word, whatever's in your story problem, all the words are going to make it important. So be aware of that every piece in there. There's not a sentence they give you in a story problem in these, as you've had in the past with story problems where they give you a whole bunch of information. You don't even need all of it. These, you usually need everything that's in there. Decide what is asked for and assign the variable to the unknown quantity. So we're going to figure out what we don't know anything about. And in this case, when you assign it, give the letter meaning. So if you're talking about air currents, make it an A. If you're talking about miles, make it an M. If you're talking about, oh, who knows what it happens to be, hours, make it an H. Don't just start sticking X's and Y's in unless you have to within Hawks, because the more meaning that you give those letters and the more that letter has something in relationship to that story problem, when you get your answer is going to make a big difference with that. So you want to watch that and make sure that you give that letter some meaning. So it has so the letter designates what you're looking for. Draw a diagram or set up a chart whenever possible. We're going to do that with quite a few of these today, because charting them ends up giving us what our values are going to be that we're going to work with. Form an equation that relates to the information provided. So that equation is going to be what we're going to end up solving and coming up with what that solution happens to be. Then solve the equation, and finally we're going to check the solution with the wording of the problem, be sure it makes sense. So if you end up with a negative and you're looking for distance, that negative problem you can kick out. You don't have to use that, okay? And so be aware of that and make sure that you're taking that piece in consideration, and so that you don't end up using a negative for your answer. Okay, so getting into these things. So we hop right in, and this one we need to put into an equation form. It says the denominator of a fraction is 8 more. This one's not in your packet. We do have some that are like it, so we will run across those in there. The denominator of a fraction is more than the numerator, is 8 more than the numerator. If both the numerator and denominator are increased by 3, the new fraction is equal to 1/2. Find the original fraction. So what pieces do we have in here? It says reread the problem. Be sure to understand it. So what do I have? Well, I've got the denominator of a fraction is 8 more than the numerator. So what does that mean? Yep, numerator is x. The denominator is x plus 8. Okay. So or we could say n in there if we're talking numerators. So you could say n is over n plus 8. Then it says if both the numerator and denominator are increased by 3. What does increase mean? Increase means I need to add something to it. So I'm going to plus 3 here, and I'm going to plus a 3 there. So I'm adding 3 to whatever that happened to have been. It's going to equal 1/2. So that becomes my equation to solve, and this is pretty much like what we just got done doing, and what that comes up with. So that's how that one happens to set up. So if we finish it, have x time, or 2 times x plus 3. equals this piece, x plus 8 plus 3 times 1, or x plus 12. And finishing it, 2 times x is 2x plus 6 equals x plus 12. Move my x over. Oh, 8 plus 3. Oh, yep, thank you. Good thing you guys are paying attention out there. Is 11. Thank you. And so then if I minus 6, I find that x is equal to 11 minus 6 is 5. So x equals 5. So is that what they're asking me? It says find the original fraction. So what would my original fraction be? So it was x over x plus 8, or 5 over 5 plus 8, or 5 over 13 was the original. And if you add 3 to each of those, I will end up with 8 over 16 if I check it. And sure enough, 8 over 16 reduces to a half. So we ended up coming up with what we needed to for this one. Okay, big mistake if I would have left that 12 in there. Would not have worked. But anyway, that's what we do with it. Okay, questions with this one? Okay, and the next one is a carpenter can build a certain type of patio cover in 6 hours. His partner takes 8 hours to build the same cover. How long would it take them working together to find this type or build this type of patio cover? What do you think with that one? So what we need to do is first get it in how much do they work per hour? So what is their value of what they come up with? So one can do it in 6 hours, the other one can do it in 8 hours. So if we take that and we chart it, and I don't know if I can get let me see if I can get my chart up here with it at the same time. I don't think I can. I think they're going to cover each other up. But anyway, the carpenter takes 6 hours. His partner takes 8 hours. Together, it's going to take them X hours to end up doing their project. But if we break it down in what's done in an hour, then we can do some comparisons and work this problem out. So if I say 1 hour is 1/6 of what the job would be, so in an hour, he can get 1/6 of the job done. The partner can get 1/8 of the job done. And together, they can get 1x of the job done. So you want to make sure that you put those pieces together and come up with what your value is. So our problem is right in here. 1/6 plus 1/8 equals 1 over x. So if we write that in that format, so I'm going to take this piece off of here. You guys okay? Can I move it? And we're going to work that out. So 1/6 plus 1/8 equals 1 over x. Again, that's out of focus. Not sure why. Focus back up. There we go. Probably bumped it or something. So I need a common denominator between 6, 8, and x. Well, 6 is 2 times 3. 8 is 2 times 4. And x is just x. So I'll find my LCD is 2 times 3. 4 is made up of 2 times 2 times 2. So I need 2 more 2's. And I need an x. So my LCD is 2 times 2 times 2 is 8 times 3 is 24x. If I multiply it by all the pieces, six goes into 24, 4. 4 times 1, or 4x times, gives me 4x. 8 goes into 24, 3x times 1 is 3x. And x goes into 24x 24 times. So 4 plus 3 is 7x equals 24. Divide by 7. So we can find that working together, it takes them 24/7 or 3 3/7 hours to do the job together. Questions with this one? And this is a work problem. This is considered a work problem. So all work problems must be calculated out to a part per hour. So if it's 8 hours, it equals 1/8 per hour. So you need to calculate that stuff out and get it so it works that way. We got some more of them in your handout to do too. So there's some more in there that we'll take a look at and get an idea of what we got to do to them. Questions with this thing? It's again breaking them apart into separate pieces. The next one is another work problem. It says a man can wax his car 3 times faster than his daughter can. Together they can do the job in 4 hours. How long would it take each of them working alone? So let T equal the number of hours the man alone will work on the car, and 3T, the number of hours his daughter can work on the car. So what comes out of this piece? So we end up with 1 over T. We end up with 1 over 3T if you break it down in hours. And 4 hours is the total amount, or 1 over 4 would end up be how long per hour, a quarter of the car or a quarter of the time would be placed into that. And so you chart it. T, 3T, 4, 1 over T, 1 over 3T, and 1/4. And then from there, we can end up working the problem out and putting it 1 over T plus 1 over 3T is equal to 1 over 4. LCD, T, 3T, and 4. What can we come up with? So we know we have a T. We know we have a 3. And we also know we have a 4, or 12T would be my LCD. Multiply the whole thing by 12T and end up with 12 plus 4 is equal to 3T. Divide by 3 to get T by itself and end up with 16/3 equals T, or T equals 5 1/3 hours is how long it would take to do the job. Questions on work problems? I don't know. Is it okay or not okay? I never hear much out of you guys, so I don't know. Yes, maybe? Okay. Okay, so let me get this thing out of there. And now let's go to your problems that you have in your handout. The first problem, let me go back and see if I can find it that you had on there. It was in my 7-4 notes. And it's pretty much the exact same one that we had up here before. So a man can wax his car in 3 times as fast as a daughter. So it's the same one we just got done completing. So that one I'm not going to end up going back over for your problems. So next one, man can row his boat. This is a distance one that we're starting to look at now. We're kind of getting away from the others. It says a man can row his boat 5 miles per hour on a lake. On a river, it takes him the same time to row 5 miles downstream as it does to row 3 miles upstream. So anybody do that? Canoeing? Anybody canoeing? That does canoeing. Why don't they run the canoe race from Oscoda to Grayling? Upstream. You would wear the guys out so bad, and the women in that race, they would never make it because the current is going to push towards them. So what does the current do then to your speed of paddling? It slows you down. When you're going upstream, it slows you down, so that's a subtraction thing happening. When you are going downstream, what does it do? Helps you, yeah, pushes you farther. So that's why in the canoe race they go from Grayling to Oscoda, because they have the full current of the river helping them to move and helping them to go forward. Of course, when they get over by Mayo and they get that wide, big wide stretches of the river, they got to really paddle in there. But in most cases, the river helps them, so it gets them going faster. So if we look at this one, this is what's called the distance equals rate times time problem. And if we solve for certain pieces of this, like if I wanted to solve for rate, I could just take the distance, divide it by the time, would give me the rate of speed. Or if I want to solve for t, the distance divided by rate will end up giving me what my time happens to be. The one we're going to use is getting distance over rate equals time by itself. I'm getting time all alone. So if we take a look at this problem and we chart it, that's probably our best bet to do with this thing. So break it into 3 parts. So my distance equals rate times time. And so we have downstream and we have upstream that we're working with. So what do I know? It says a man can row his boat 5 miles per hour on a lake. What do we know about lakes? What about the water in a lake? No current. There's just a lake, okay? It gets rough and choppy, but it doesn't make a current, okay? So it gets rough and choppy. You're just kind of going up and down, but you're not moving anywhere. So it's pretty constant. So what does that mean? So if he's out rowing his boat, so what that means is a guy normally rows his boat at 5 miles per hour, okay? So his rate is going to be 5 miles per hour if he were in a lake, okay? So if you're in a lake and he went down the lake and went back up the lake, he's still the same amount of time, right? It'll take him 5 hours to get down as it does 5 hours to get back. But in our river, it says on a river, it takes him the same time to row, so the time is the same. To row 5 miles downstream as it takes to row 3 miles upstream. We good so far? Basically, all I did was just pulled stuff in there. So what happens now? We all agreed if he's paddling downstream, he's going to go at a faster rate, right? Because it's going to move him right along, and he's going to go, 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 go. Okay. If he's going upstream, the current is going to cause him to paddle slower because he's got to fight the current to get there. We good? Okay. So what about our time? We know it's the same, so that means that downstream is equal to upstream. but time is the same. So how do I get the figuring out what time equals? Well, up here, distance divided by rate equals my time. So in the first one, it's 5 divided by 5 plus r is my time. My upstream is 3 divided by 5 minus r. And because they're the same, my formula is 5 over 5 plus r is equal to 3 over 5 minus r. And so I end up with a proportion. Can you guys solve that one on your own, you think? I think with these, it's more setting them up than it is maybe solving them. Do we need to solve it, or can you do that on your own? What do you guys think? I just got to take this times that and this times this. So maybe we should just go through and do this one. So it's going to be 5 times 5 minus r is equal to 5 plus r times 3. So I get 25 minus 5r is equal to 15 plus 3r. Get all my r's together. Get all my numbers together. And I get 10 is equal to 8r. Divide by 8. And I find r is equal to 1.25 miles per hour would be the speed of the current of the river. So 1.25 would be the rate of my current. So that's what we'd end up doing to solve this one. Charting is important, so you want to make sure you chart stuff and put in your rate, your time, and your distance. Was there any piece of information in here that was given to me I didn't need? Or was all of it important? I know, but it's probably pretty much important because there isn't anything else that they give you. Okay, so if we push it up and we take a look at the passenger train. Not the train problems that they talk about, the infamous train problems where you have absolutely no idea of when something does what. Made my chart a little bit too long there. If a passenger train, so I have a passenger train, travels 3 times as fast as a freight train, so we got a freight train, passenger train, and freight train. So it's a charted piece. 3 times as fast, 3 times as fast as a freight train. What does that tell you? The passenger is going 3 times as fast as a freight train. What does that tell me about how fast? How fast is my freight train going? Freight train's going, passenger train's going X. Who's going X? The passenger is going X, and the freight train's going? Yeah, yep. And like I told you last time, if we can give it some meaning, let's give it some meaning. We're going to make this F for freight train and 3F for the passenger train. Because when I get all done, I need to know what's the speed of each train. So if I have F in here, I'm not going back and thinking about which train did I have? What was X associated with? I know if I have F, F's the speed of the freight train. Okay, so I kind of got one thing solved for, and I don't have to go back and think about it, of what happens with it. The freight train takes 4 hours longer to travel 210 miles. What is the speed of each train? So the freight train's going to take 4 hours longer to travel 210 miles. So what's my distance? How far are these trains traveling? 210 miles. Both of them have traveled 210 miles, correct? Okay. We agree? Okay. So what do we know about their time? Takes the freight train 4 hours longer than the passenger train. And that's where this gets a little bit trickier, because the time in here that you will have is 210 divided by 3f. The time here is 210 divided by f. But our problem is this 4 hours longer. So that means this takes 4 hours plus the amount of time it takes this one. So to do these is you take the freight train minus the passenger train is going to equal 4 hours. So time of the freight train minus the time of the passenger train is equivalent to 4 hours. And so that's kind of the tricky piece, because we just can't set them equal to each other because the time's not the same. So then you would end up solving it, coming up with your common denominator of 3f, and end up going through and finishing it. Do we need to finish it? Yes? No? Be careful with these type. Put a star next to it. You will run across those in your homework. Because again, it takes 4 hours longer, so you've got a subtraction going on there. No, I cannot cross multiply with this one. The question was, can I cross multiply? The minus sign is in there, not the equals. Okay, so be careful because there's a subtraction there. So I would come up with my LCD of 3f. So f goes in there 3 times. So I have 210 times 3 minus 3f, and 3f, it's gone, minus 210 is equal to 4 times 3f. And so when I solve this, I end up with 630 minus 210 is equal to 12f. 630 minus 210 is going to be 420. Divide by 12. And I would find f to be 35. So the freight train is going at 35 miles per hour. How fast is the passenger train? I guess we ended up solving it. So the passenger train is 3 times 35. Yep, 105. Okay, so that's my 2 speeds. So I'd have to go through and end up figuring out what those would be. Questions with this one? Again, it's just kind of going through and figuring out what ones go where with what you have. Here's another one. It says an airplane can travel 405 miles per hour in still air. If it travels 1,287 miles with a wind in the same length of time it travels 1,143 miles against the wind, what is the speed of the wind? So we have still air speed. We have the distances of each piece. So we again chart this. And we have with wind and against. So 405 in still wind, but what's the wind doing? If it's going and pushing it, you've ever flown on planes and they say, oh, we're going to get in 10 minutes early. That means you were flying with the wind pushing the plane. If you get in 15 minutes late, that meant the wind was pushing against the plane, and that happens all the time. I think you hear that all the time. Oh, we're going to be a little bit late because of the wind conditions. So this is a plus the wind. This is a minus the wind in that situation. Our distances 1:12:87 and 1:11:43. And so then we would set this up. The time is going to be 1:12:87 divided by 405 plus W. And the other one is 1343 over 405 minus W. So our equation is this is equal to that. Notice it says the same length of time. So that means they're equal to each other. Yes. Yeah, the question was, can you cross multiply with this one? And yes, you can, because this can get multiplied by that and that can get multiplied by that because there's nothing in common between the denominators. So you can just cross multiply. So 1287 times 405 minus W is equal to 405W times 1143. And you can solve it from there. We'll leave that one open and you can finish it with what you need to do with that one and come up with your wind speed. We set up the next one. One number is 1/2 of another number. So we have the first number and the second number. And what do we know about them? One number is 1/2 of another number. So what one don't I know anything about? Does it make a difference which one I set up as being 1/2 x and the other one x? Does it make any difference? Not really. We can say that one's x and the other one's 1/2 x. The sum of the two numbers is 3. So x plus 1/2 x is equal to 3. And then we can, you guys I think can do that from there. Common denominator is going to be 2. Everybody gets a 2. So x is equal to 2. 1/2 of x is 1, and sure enough, 2 plus 1 does equal 3. So pretty easy with that one. See what you can do with the next one. I wanted to make sure I gave you enough examples of the different types you'll run across in your homework assignments. So that's why we have so many story problems. I didn't want to leave you without certain varieties of those. This one's like that starred one that we just did. When I told you to put a star next to it. It's like it. Make sure you chart all this stuff so that you can get your pieces in the right place. And if you chart them, then you're doing good with that part. Okay, so chart those and make sure that you get your pieces out of them. So Jose is riding his bike at 19 miles per hour. That's going pretty quick with that one. Okay. These next two are similar to ones we have just solved, so I think we're going to skip those two. But there is one I did want to show you, and that is the in a church. Find that one in your notes or in your sheets there. And I will go back through and work these other two out. So if you want to check your notes later, it'll be posted in Canvas, and they'll be there. So they'll be worked out in there for you. So if you want to go back and see what happened with those two. It says, in a church, a ratio of adults to children is 12 to 11. If there are 460 people in the church, how many children are there? Well, the trickiness to this one is this is adults to children. So 12 to 11 is adults and children. But the problem is this 460 is people. So can I just put that in and set it up with this? If I put 460 on top over X children, will it work? No, it won't work because this is everybody in the church. That's adults and children. So I need to take this part and add it together. 12 plus 11 gives me 23 people. in my ratio compared to 11 children. So I need to make sure that I go back through this one and end up solving that piece. So make sure you're careful right here in getting your people to children and not adults to children. Then I can set the rest of it up. And end up solving it. So I just wanted to bring that to your attention, that you have to be real careful and read those. And those do pop up in your sheets as well with that. So be careful on that one. Pardon? Yeah, as long as there's an equals. If there's ever a subtraction or an addition, you can't. But this one you can just cross multiply and end up with 23x is equal to 460 times 11. Then divide by 23, and you will end up finding out what x happens to be. So there's 220 children would be what you'd have in that one. Okay? And then the last one there, I'll also work this one out and put it in the notes as well. Okay? Questions with story problems? Anything? All right, now I'm going to shut this thing down.